Hello, my champions. In this video, we're going to learn something interesting about a right-angled triangle. You've learned about triangles, right? And the triangle which has a right angle, that is a 90 degree, is called as a right angle triangle. And now we're going to learn some specific names for these, the sides, okay? Especially the longest side, the pink color side, it will always be opposite to the 90 degree. This will be the longest side, and that is called as a hypotenuse. It's called as a hypotenuse. Okay. Let's learn about this one side because it's special because it is opposite to right angle as well as it is the longest side of a right angle triangle. It's called hypotenuse. Now, there's an interesting theorem called the Pythagoras theorem. The Pythagoras theorem comes from a mathematician, Greek mathematician, Pythagoras. He says that in a right angle triangle like this, okay, if the length of this side, the blue color side is A, and the green color side is B, that means length of these sides are next to the right angle itself, okay, adjacent to the right angle. And if the hypotenuse length is C, then he says that A square, the square of the length of this side, plus B square, that is when we square the sides and add it up, the sides which is next to the right angle, that will be equal to the hypotenuse square. Now, let's prove this thing visually. Okay, let's prove this visually. What does it mean by when we say a square? It means it is a square number, isn't it? Square number. And square numbers, we also know it can be represented as a square. That means if A is a length of a side, A is a length of a side, then A square will be the area of this. A square will be area of the square, which is having the side A, isn't it? So now we're going to draw squares. Okay. If 3 is a side here, what I'm going to do? I am going to draw a square like this. So just a square based on this side A. Next, I'm going to draw a square based on this side B. 4 units this side. So I'll come 4 units this side basically. And I will have like this. The square of these things means he's telling that now this square, whatever is the area, it is 16, isn't it? Now, how is it 16? Because 16 small units of squares, small unit squares are here inside. Now, similarly, the area of this triangle, this square is 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the area of this is 9. Now, he says it is equal to the area of the square standing on the hypotenuse. Let's draw a square which is standing on the hypotenuse. Now, if you see here, it is, let's use a protractor also, okay? Let's use a protractor and draw the 90 degree lines and things like that, right? Let's do that. And let's take the compass also, okay? For the fun of it, okay? Okay, so, okay, here is our, because in a square we know it's a 90 degree, isn't it? So let me mark it. Here is my 90 degree. Okay. Once that is done, let's take a 90 degree at this end also. I can always draw a square just like that, but I don't want to mislead. We are doing an experiment, right? We're trying to prove Pythagoras. So let's do it, do it the authentic way. Do it the authentic way, basically, right? Okay, now I have these lines I have to join them. So let me join them. From here, I'm trying to join. I'm going to draw an extra length so that when we can measure the actual length from this compass and then do it as well. Oh. Okay, here is my 90-degree line, and here on this point is my another 90-degree line. Okay, once that is done, what I'm going to do, I'm going to take this length of this side, the hypotenuse side, going to measure that here, and I'm going to keep the same thing on the, okay. So here is my length, right? So I'm going to take this length. I'm going to cut an arc here. Means it will be the same length, isn't it? Of the hypotenuse. So all the squares sides are equal. So I'm going to do the same thing here as well. So I'm getting the, oops, oh, I measured. I did not, 1 minute. It got changed. No, it is not got changed. It is not got changed. So it's same. So let me do. Okay, I have cut this. So I know now this is at 5 degree. Okay, this is at whatever the length of the hypotenuse, this exact same length is there. I'm going to join these two lines. Now this is my square. This is a square on the hypotenuse. Now we have to find the area, right? Just like how we found the area of the other things, let's find the area of this. So this complete square means I'm going to mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is sure. 13. Then 14, this one, because almost full, 14, 15, 16, 17, almost full they are. 17, 18, 19, 19, and this side together is 20, 21, these two together, 22, right? Then 23, 24. Okay, maybe I missed something. Let me do it again. We are doing experiment, right? So yeah, some trials we might be requiring. Okay, this is going to be fun. That's all. See, you can always mug it up and learn and go, but then we can do an experiment. That's what I'm trying to do. Okay, let's try to do an experiment. Maybe I missed some counting. Let's see, because it's like haphazard. So let me do it systematically. Okay, all the complete squares 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now I'll do the half square. 13 is done. Let me not forget it. Okay, half squares are here. 1, this is 1. Then, right, half squares 2. So two half squares. Almost full squares are here. 1, 2, 3, 4, 5, 6, 7, 8. 8. What am I left with? Okay, another 1 I am left here. Plus 1. Okay, I had left here. Anything I'm left here? Yes. Look at this. 1 here. Together, these two, 1, 2. 1 here together. Okay, let's count it all together. 13, 14, 15, 16, 17, 18, 19, 25. Right? So now we know the area of this is 25. And what does our Pythagoras say? Not our Pythagoras, of course, Pythagoras, Greek mathematician. He says that a square, which is 16, a square is 9, b square is 16, is equal to c square is 25. And that's absolutely correct, isn't it? 9 plus 16 is 25, and we have proved it by adding the squares, like actually finding the area of the squares as well, right? So Pythagoras theorem is when you are going to work with the sides of a right angle triangle. Very important to remember, in a right angle triangle, when you know two sides, you can always find the third side. How is it? How is that we can do that? Okay. How is it that we can do? Like for example, now let's say it was given to you that this hypotenuse is 10 and one of the other side is 6. Hypotenuse means the longer side, right? I know this is 10, this is 6. I don't know this. So this is a question mark, or I can put an x here. So what do I know? I know that x square plus 6 square is equal to 10 square. This is as per the Pythagoras theorem, isn't it? Now how I have to find this? So simple, x square will be equal to 10 square minus 6 square. 10 square is 100. 6 square is a 36. Then I get x square as a 64. If x square is 64, then x will be 8. That means this will be 8 centimeter. So, in a Pythagoras, in a right angle triangle, using the Pythagoras theorem, if we know two sides, the other third side, we can find out using this relationship. Okay, very important to note that this hypotenuse square should always be on the one side. Other two squares have to be on the other side of the equation. That's it. Start from there and then use your algebra skills and find out the other side. Okay, when you are dealing with all three sides of a right angle triangle, that is when you use Pythagoras theorem. Okay, remember this fact, remember this technique, remember this trick, whatever you call it. Okay, when you're dealing with three sides of a triangle, of a right angle triangle, you'll be using Pythagoras theorem. I'll see you in the next video. We'll talk more about right angle triangles. Until then, see you. Bye-bye, my champions.